Before we discuss how to answer these three items, let's have some notes first about differentiation rules. When we see constant rule, it says that the derivative of a constant would be 0. For a power rule, if we have a function x to the power of r, its derivative will have the coefficient now r, and the new exponent will be r minus 1. Using now constant multiple rule, if we have a constant that is being multiplied to a function f, its derivative would be that constant c times the derivative of our f. Before we continue to other rules, let's have some examples first to illustrate these rules. Knowing that the derivative of the constant would be 0, if we are to get the derivative of 10, and 10 is a constant, automatically the answer would be 0. Next, if we have a function x to the power of 6, using power rule, its derivative will now have the coefficient 6, which is the original power, and our new power this time would be 6 minus 1, which is 5. Power rule also applies with the negative exponent, so if we have x to the power of negative 5, its derivative would now be negative 5 times x to the power of negative 5 minus 1, which is negative 6. As for constant multiple rule, if we have a constant that is being multiplied to a given function, say 7x cubed, its derivative will now be 7 times the derivative of the x cubed. And applying power rule to that x cubed, we have 7 times 3x to the power of 3 minus 1, which is 2. Next would be sum rule. It says that if we want to get the derivative of the sum of two functions, we just have to get the sum of the derivative of each of the functions. That is, the derivative of the sum of the functions f, g will just be equal to the derivative of f plus the derivative of g. This idea would also extend to finite sum rule. As for the product rule, if we have the product of two functions, say f, g, the derivative of this product would be first function f times the derivative of the second function, which is g, plus the second function, which is g, times the derivative of the first function, which is f. To picture this out, let's have this example. Say we want to get the derivative of 2x cubed times x to the power of 6. Product rule says that we have to get first the first function, which is in this case 2x cubed. Then we multiply this to the derivative of the second function, which is x to the power of 6. In getting the derivative of x to the power of 6, notice that when we apply power rule, x to the power of 6 becomes 6 times x to the power of 5. Next would be writing g, or the second function, which is x to the power of 6. This will be multiplied to f prime, or the derivative of the first function, which is 2x to the power of 3. In getting the derivative of 2x to the power of 3, we can use constant multiple rule and power rule. Thus, we now have the constant 2 times the derivative of x cubed, wherein we use power rule that gives us 3x squared. And simplifying this gives us 6x squared. Now getting their products, we now have 12x to the power of 8 and 6x to the power of 8. If you want to review on laws of exponents, the reason why we have x to the power 8 here, just click the I icon there at the upper right corner of your screen for the suggested video. Simplifying this, we now have 18x to the power of 8. Now let's have quotient rule. Using quotient rule and getting the derivative of f divided by g, it would be denominator times f prime, or derivative of the numerator, minus numerator f times g prime, or derivative of the denominator, all over the square of the denominator. To illustrate quotient rule, let's have this example. say we are to get the derivative of 3x to the power of 5 all over 2. So first we have to get the product of the denominator, which is 2, and the numerator's derivative, which is the derivative of 3x to the power of 5. Notice that in getting the derivative of 3x to the power of 5, we are to use constant multiple rule. Thus, we have 3 times the derivative of x to the power of 5, wherein we are to use power rule this time, so that would be 3 times 5 times x to the power of 4. And this results to 15x to the power of 4. This time, we have to subtract the product of our numerator 3x to the power of 5 and the derivative of our denominator 2. Observe that our denominator is a constant, therefore its derivative would be 0. And the difference of these two products would be all over the square of the denominator, which is 2 squared. So the first product would give us 30x to the power of 4, and the second product would be 0. Thus, our numerator will just be 30x to the power of 4, and we now have our denominator 4. Simplifying this, we'll now have 15x to the power of 4 all over 2. Let's now apply these differentiation rules in answering these 3 items. For our first item here, notice that 5 over x to the power of 4 can be written as 5 times x to the power of negative 4. If you want to have a review on laws of exponents, we have a discussion on negative exponents on that suggested video. Now, in getting the derivative of this function, we can just use constant multiple rule. And so we have 5 times the derivative of x to the power of negative 4. This time, in getting the derivative of x to the power of negative 4, we can use power rule. So we have negative 4 times x to the power of negative 4 minus 1, which gives us negative 4 times x to the power of negative 5. And so simplifying this, we now have negative 20 times x to the power of negative 5. Again, we have a suggested video on operations on integers in case you want to review that. And yes, law on negative exponent can make this negative 20 over x to the power of 5. In case you forgot on how to do negative exponent, definitely for this function we can use quotient rule instead. And so applying the algorithm of quotient rule, we have denominator x to the power of 4 times derivative of our numerator 5 minus the numerator 5 times derivative this time of our denominator, which is x to the power of 4. And this would be all over the square of our denominator, which is x to the power of 4. Solving the derivatives of the numerator, notice that the derivative of 5 is 0 using constant rule, and the derivative of x to the power of 4 would be 4x cubed using power rule. And our denominator here will be x to the power of 8. If you are confused on how come this becomes x to the power of 8, that will be part of the suggested video laws of exponents. Now, x to the power of 4 times 0 is 0, so our numerator here will just be negative 20x cubed. And this would be divided by x to the power of 8. And simplifying this gives us negative 20 over x to the power of 5. Now for a second item, in getting its derivative, we just have to use finite sum rule, and so we have this. For the derivative of 1/8 x to the power of 8, we just have to use constant multiple rule. So we have 1 over 8 times the derivative of x to the power of 8. As for the derivative of x to the power of 4, we can now use power rule, and so we have 4 times x to the power of 3. Clearly, for the derivative of 2 cos x all over x plus 1, we are to use quotient rule. So g here means denominator, so we have to have x plus 1 times f prime, which is the derivative of our numerator 2 cos x, minus f, or the numerator 2 cos x, times g prime, or denominator's derivative, all over the square of our denominator. Now, derivative of x to the power of 8 using power rule becomes 8 times x to the power of 7. For the derivative of 2 cos x, we have to use constant multiple rule. So this would be 2 times the derivative of cos x, which is negative sine x. For the derivative of x plus 1, using sum rule, we have to get derivative of x, which is 1, plus the derivative of 1, which is 0. So that would be 2 cos x times 1, which is just 2 cos x. Simplifying this algebraically, we now have this. Here, 2 times negative sine x is negative 2 sine x. Distributing this to our x plus 1, we have negative 2x sine x minus 2 sine x. Here, we may factor out negative 2. For item number 3, I'll be giving you 2 possible ways. First, let's make use of a negative exponent, so that 3 over x squared can be written as 3 times x to the power of negative 2. So for its derivative, we now have this. Since the derivative of x will just be 1, we now have negative 6x to the power of negative 3 minus 5 halves. For another method, we can have 3 over x squared minus 5x over 2 in a single fraction. If you want to review on how to do this in operating fractions, just click our suggested video. With this single fraction, we can now apply quotient rule. This is where the importance of familiarizing differentiation rules comes in. That is, if you are familiar with different techniques, you can find the easiest and fastest way to solve for the derivative.